Now, Webster's method is the only one that uses a rounded number like we're used to rounding. Like if you have 3.4, your answer would be 3. If you have 3.5, your rounded answer would be 4. And it does exactly what Jefferson's did. It has a standard divisor, and then sometimes you have to modify it. If you're lucky, you don't have to modify it. Alright, so this population is 4,400. So we still have to find our standard divisor, which is your total population divided by how many seats. Well, in this case, we have 20 seats. So our standard divisor should be 2,200. Or 220, sorry. 220. So our standard divisor is 220, and we're going to go through and see if our quotas will round up nicely and give us exactly 20 seats. If not, that's okay. So 800 divided by 220 is 3.636. 1300 divided by 220 is 55,909. 600 divided by 220. Since the number is 220, it's you get these neat little patterns. 727, 27, 27. So that one becomes that. 1,000 divided by 220 is 4.545. And 700 divided by 220 is 3.1818. Well, 181. Well, 182 if you round it. Alright, so then you go to the next. Sorry about the color change. My computer crashed yet again. Alright, so the quotas rounded would be 4, 6, 3, 5, and 3. Now we're just doing straight rounding here, unlike the round down before. I think in one of my other videos I said we always round down for all these methods, but Webster's doesn't. So if we add these all up, we get 10, 13, 18, 19, 20, 21. So it's too many. So what we need to do is make the divisor bigger so we can make this number smaller. Now if we're going to make this number smaller, we want to pick a value to play with that's rather close to going the other direction. So we're looking for the smallest out of all these numbers, which would be this 181 down here. Not the smallest of all these numbers, just the smallest of the last 3 digits. So if I play with 3181 and I make my divisor bigger, I could try 230. So I can take the 700, divide by 230, and see if it goes to 2 point something. If it does, I'll try that for all of them and see what happens. So 700 divided by 230 is 3.04. So I think using 230 as a divisor is going to work. So let's do this in red. So I'm going to change everything into divisors by 230. Alright, 230. So 800 divided by 230 for 3.47. Oops, change my marker. 3.478. 1300 divided by 230 is 5.65 and 2. And 600 divided by 230 is 2.609. And 1,000 divided by 230, sorry about my voice, 4.348. And 700 divided by 230, 3.043. Alright, so let's see what happens when we round them. This one stays 3, this one is 6, this one is 3, this one is 4, this one is 3. So let's see, that's 9, 15, 16, 17, 18, 19. Uh-oh, went too small. This might be one of those problems that we have to go in between. So 230 didn't work. So I would go somewhere between 220 and 230. So I'm going to try 225. I think using 230 changed two of the numbers down rather than one. I just can't remember which. I could backtrack and find out, but something changed besides the 3 down here. My guess would probably be one of these two numbers here. Alright, so maybe 225 back. No, it was 220. It was that weird number. We're going to try 225. And I'm going to edit this video to no end. Alright, so 800 divided by 225, 3 point and a bunch of 5s. 1300 divided by 225 is 5 point and a bunch of 7s. 600 divided by 225 is 2 and a bunch of 6s. If I remember right, that was 3 last time, so this one dropped 1, which is good. 1000 divided by 225 is 4 and a bunch of 4s. And 700 divided by 225 is 3 and a bunch of 1s. Alright, so if we round, this becomes 4, 6, 3, 4, 3. That's 10, that's 17, 18, 19, 20. So we got our 20. Alright, so our apportionment is literally going to be the 4, the 6, the 3, the 4, and the 3. And these would be how many representatives represent each one of these regions in this town by Webster's method.